Hey there, you. Yes, it's you. Hi there. Welcome to this session. For today, we are going to discuss about expression tree. So, what is expression tree? So, when we talk about expression tree, this is a specific kind of a binary tree that is used to represent expressions. Two common types of expression trees are binary expression tree that can represent either an algebraic expression or a Boolean expressions. These trees can represent expressions that contain unary and binary operators. So here, as I've said earlier, there are actually two types of expression trees. We have the algebraic expression trees and Boolean expression trees. For this session, I'm only going to discuss about algebraic expression tree. Okay, so what is algebraic expression tree? So remember that in our RPN or reverse Polish notation, we have uh, determine the operands. So operands can be any variables or constant values like 3, 7, 9, or X, Y, Z. And then when we talk about binary, the operators or the binary operators, it could be any arithmetic operators or the modulus division or exponent, no, or exponential notation. So when we talk about unary operators, the sign of a number. Okay, so where each node is actually an operator and each leaf is an operand. So a binary search tree, sorry, an expression tree is any node with an operator should be with any node with the node should be an operator or and the leaf should be or must be an operand. So as you can see here, you have as an example of algebraic expression tree, you have the node as the operator. Okay, you have operator node plus here, and then another operator node plus, which is multiplication, and then we have here the leaves as the operands, 3, 7, and 9 respectively. Okay, so for your Boolean expression trees, we have here an example. So and or most likely the most common Boolean operations or operator are actually and, or, and, not. So you have here and or, and then the operands are the leaves. That is for Boolean expression. Now, what is the property of an expression tree? So again, I've already told you earlier that all leaves should be an operand. So example of operands are values or actual value or a variable like A, B, C, then 6 and 100. And then the root or the internal nodes must be an operators, either addition, subtraction, multiplication, division, or exponential or exponent. So subtrees are sub-expressions which with the root begins an operator. So if a node is not a leaf, then therefore it should be an operator. If a node is a leaf, then therefore it should be an operand. So there are different types of expression formats. So in our discussion about reverse Polish notation, we discussed about prefix, infix, and postfix. Now to implement or to create an expression tree, we have to have an idea about the RPN or reverse Polish notation. So you have here prefix expression, infix expression, and postfix expression. So you have here the in if we are going to present it in a or present it in a binary expression tree, you have here addition, subtraction, addition, subtraction, and then the leaves are the operands. Okay, so I guess you already understood it because we already discussed about reverse Polish notation. So now let's discuss about again, this is how you construct an expression tree. Okay, the operator should be an internal node, and then the operands must be leaf. That is the only thing, that is the only property of of an expression tree. Internal node must be an operator, leaf must be an operands. Okay, so how do we construct an expression tree? Okay, this is the algorithm that we need to follow. Number one is, given that you have an infix notation, first is you will need to convert it into postfix. So first you will need to convert it into postfix. So the expression must be converted into postfix. And then after reading all the elements or characters from your postfix notation, you will need to you will need to um you will need to do a certain pushing and uh, pop pushing and popping operations of a stack algorithm. So if an element is an operand, push it into the stack. If ever the character is an operator, then you will pop the topmost two elements of that stack. The first top is the left, the second top is the right. Okay, so then after that, make operator as root node, construct a tree with elements as right child and left child, and then you push it back. You push it back to the stack as an element and then you are going to repeat the process until reading all elements from your postfix. If you haven't understood understood yet, I'm going to demonstrate, give a demonstration on how to do this processes or algorithm in terms of constructing expression tree. So for now, that would be all. And thank you for listening. And then please watch the next video after this. Okay, so have a great day and see you in our next session. Bye bye.